This is 7-4. We're still working with trigonometry. Trigonometry continued. We're working with inverse functions today. Now, I've been using the word inverse functions quite a bit in notes. Today, we're actually going to learn how to work with inverse functions and our scientific calculators. Okay, find the missing angle. Find the missing angle. I'm going to put in parentheses here, whole number. I want you to round to the nearest whole number. Okay, how is this different from the review we just did? And all the problems on the most of the problems on the review, we were looking for missing what? Sides. And now I'm looking for missing what? Angles. Okay, so how does that change? Let's take a look first at what we're going to be seeing. Number one, remember, we're always working with right triangles. A, B, C. This is 7. This is 15. And before I label this angle down here, I'm going to put it really quick over here. Something that we're going to be using that's used quite often in trig when you're looking for angles is the letter theta. It looks like that. It's part of the Greek alphabet, and it means theta. Like A is A and B is B, that is theta. There's alpha, theta, beta, sigma. There's a lot of different letters, Greek letters, that we use in mathematics. Quite often we're working with angles. What's so funny? What? Okay, so here's what it's going to look like. They're going to put a theta right in here. Theta is equivalent to using X or Y or Z. It's just theta is commonly used to refer to an angle. Theta is rarely ever used to label a side. It's most commonly used to label an angle. Now, theta is equivalent to using X or Y or Z, element OP. It's just a letter. It's just, we use it quite often in math to talk about an angle.
That's theta up or down?
No, it's theta. 0 with a line through it down the middle. Now be careful you do not write it like this, because that looks like undefined. So don't write it like that. It's like that. Okay, and again, we use it quite often in mathematics when we're working with angles. We use it a lot in advanced math because right now we're working with sine, cosine, tangent type problems, and beta come up quite a bit. Let's see if I can find any. And again, it doesn't have to be theta. It can be sine or cosine. There's some right here. Tan of theta, cotangent of theta. So you can see it's used quite often. We use it a lot. Get used to it because you're going to see it on quizzes and tests. You're going to see it next year. You're going to see it the year after. All right, so there's theta. I could use A, but I'm calling it theta. So they're asking us to find angle A, and they're calling it theta. All right, I had a kid ask in a class yesterday, why can't we use Pythagorean's theorem? Can anybody answer that question? Yes. We're finding an angle, not a side. Were you going to say the same thing? Yes, we're finding an angle, not a side. Okay, so here is what you do. Lucky for us, you do the same thing as if you were looking for a side. You put your pencil marking or your pen, you put your little dot in the corner you're looking for. What angle am I looking for? Angle A or angle B? A, that's where theta's at. So I put my marking there. And then I label my sides. They will always give you two sides. If you're looking for an angle, they have to give you two sides. You label them appropriately. Put your phones away, please. What is 7 in reference to angle A? It's a cross, so it is opposite. What is 15 if it's right next to it? Ooh, I said it wrong. It is next to it, but what is it? The hypotenuse, because it's across the 90. This one here is the adjacent. Kids will label this. Do I have to label the adjacent side in this particular picture? No, because they didn't give it to me. I'm not going to waste my time labeling it. All right, so again, we still do what we've always done with these type of problems, SOCA, TOA. Which one's opposite over hypotenuse? So which trig function am I going to use? Sine, cosine, or tangent? Sine. Now remember, it's always sine, cosine, or tangent of an angle, not a side. So will I do sine of 7, 15, or theta? Sine of theta equals, luckily I have things labeled, opposite over hypotenuse will be what over what? 7 over 15. So far nothing has changed. Sine of an angle equals opposite over hypotenuse. What problem are we running into right now though? The variable is theta, but can I plug this in my calculator, sine of x or sine of theta? No. Okay, so here is what we have to recognize. We want the angle, but it's not given to us. Lucky for us, people in the past have been able to program these calculators to do it for us. Otherwise, we'd have to use charts and look for numbers and do a whole bunch of other stuff. But luckily, it's programmed in our calculator. So this is how we get our calculator to give us the answer. First off, recognize we don't know the angle, but we know that sine of this unknown angle is 7 over 15. Do you guys agree with that? So we're going to ask the calculator, hey calculator, we know that sine of this unknown angle is 7 over 15. Can you tell me what the angle is? And it's going to give it to you. We just need to know how to plug it in. Okay, so again, we're going to ask the calculator, we're going to tell them first, we know sine of an unknown angle is 7 over 15. Can you tell me the unknown angle? And it's going to give it to us. We just need to know how to ask the calculator. So this is how you plug it in. Write it down first. And this next step, I will have kids say, well, I know what to do. I'm just going to plug it in. This next step, I need to see you writing it down on homework, on quizzes, and tests. If you don't, I'm going to assume you cheated. This is part of you showing your work. Are you ready? Okay, you do sine -1 up at the top there, parentheses 7/15, close parentheses, equals theta. This is how we plug it in. We call this the inverse, and I've been using the word inverse when we'll be doing square roots and x squareds, and I tell you guys they undo each other because they're inverses. That's what we're doing. Sine and sine inverse, they undo each other. So we plug in our calculator like this. Do you see your sine -1 key on your calculator? Where is it? Is it right above your sine key? Yes, and it's light green on my calculator, so I'm going to use my green key, which is second. Second, sine. And it looks, can you see on your calculator where it says sine -1? Okay, and then we type in the fraction. What was the fraction? 7 over 15. I'm just going to use my division key. You can use your fraction key if you want to. I'm just going to use division. Inverse sine, or sine inverse, of 7 divided by 15, and hit enter, and there it is. So this is the way we asked the calculator. We said, hey, I don't know the angle, but I know the sides. I know opposite is 7 and hypotenuse is 15. Can you tell me what the angle is? And it does it for you, which is amazing and beautiful that it can do it for us. Did you guys get it? 27.8181398? Yes.
My calculator doesn't have a sine -1.
Right above your sine key.
No. Oh, okay.
Found it? Okay, anyone else not able to get it? Or you can't plug it in your calculator properly? Okay, so it asks for the nearest whole number. So is that 27 or 28? 27.8 would round to 28 or stay 27? 28. So theta equals 28 degrees. This is a degree because I'm looking for an angle. And that there is your answer. Let's try another one because I can see some people are like, what the heck is going on here? Let's try another one. Okay. You're taking the test and you get to this problem and it says find theta. First thing you ask yourself, am I looking for a side or an angle? And what am I looking for here? A side or an angle? Angle. Now I'm going to put a note up here. Whenever you're looking for the missing angle, you will always be using your inverse key. You're going to be using your inverse key when you're looking for an angle. When you're looking for a missing side, that's when you use those three methods we talked about earlier. The Pythagorean's theorem, the special right triangles, and the SOHCAHTOA. When you're looking for a missing angle is the only time you're going to use your inverse key. That's your -1 key on your calculator. All right. Again, we start it the same way. Let's mark our angle. What angle am I looking for? A or B? A. What is 5 in reference to A? They both look adjacent. Which one is which? 5 is adjacent and 12 is hypotenuse because it's the longest side. It's opposite the 90. All right, so looking at SOHCAHTOA, which one is it? Is cosine the adjacent over hypotenuse. So when you write it, you write cosine of 5, of theta, or of 12. Theta, because we always do sine, cosine, or tangent of an angle. Cosine of theta. We have it labeled, so what's adjacent over hypotenuse? Okay, so we just said it. When you're looking for an angle, what special key are you going to use in your calculator? The inverse key. Now, in order to do that, don't plug it in yet, you have to write it on your paper for me, otherwise I'm going to assume you cheated. Cosine -1, what comes next? 5 over 12 equals theta. And no, you can't tell me, well, I didn't know what to write, because what you're typing in your calculator is what you're writing. That's exactly what you type in your calculator. Second cosine, 5 divide 12, close parentheses. You're typing in exactly as you're writing it down. Equals 65.37568165. Does that round to 66 or stay 65? Okay, so again, you are telling the calculator, hey, I don't know the angle, but I know its adjacent side is 5 and its hypotenuse is 12. Can you tell me what the angle is? And it calculates it for you and gives it to you. Make sense? All right, another one. Number 3. Which angle am I looking for this time? A or B? B. So put your little dot at angle B and label the 7 and 12 accordingly. Are either of those numbers the hypotenuse? No. One's opposite, one's adjacent. What is this one here? If it's a cross, is that opposite or adjacent? Opposite. And what is the 12? Yep, adjacent. SOHCAHTOA. Which one is opposite and adjacent, or opposite over adjacent? TOA. So which trig function am I going to use? Sine, cosine, or tangent? Tangent of 12, 7, or theta? Tangent of an angle. equals 12 over 7 or 7 over 12? How do we know it's 7 over 12 and not 12 over 7? Opposite over adjacent. Good. All right, before you plug it in, how do you write it on your paper? Tan negative 1 what? 7 over 12 close parentheses equals theta. You write down what you're typing in your calculator. Second tan, that's our inverse key. 7 divide 12 close parentheses 30.25643716. Did you guys get that in your calculators? Okay, whole number. What is that? 30 or 31? Sorry. 30 degrees. Questions? Are we good? All right, take out your packets. Oh, nah. It's a new packet. I'll get it out to you right now.